Hi, good evening. Yeah, another session of thermodynamics. आज हम लोग बात करेंगे लैटिस एंथैल्पी की and a few more enthalpies of solution और एक दो ऐसी चीजें हैं. So, continuing जो हम लोग last time कर रहे थे. And I know यहाँ पे लिखा है ना लैटिस एंथैल्पी और spontaneity. Yeah, we're gonna go towards that. We won't talk about the third law of thermodynamics so much, but at least हम लोग spontaneity आज introduce करेंगे. And in fact, second law भी कुछ एक्सटेंड तक ही करेंगे. We'll do that next time. Yeah, third law is not in your syllabus. But anyway, so for now, you know the drill. NCERT खोल के देखते हैं क्या आज करने वाले हैं. Let's do that right away. See, this is a part of thermo जिससे आजकल ज्यादातर सवाल आते हैं. The other part that has a bit of derivation stuff, not so much, but यहाँ से yeah, quite frequently. So we'll quickly check that out. Are you able to hear me and see me? Let me know in the comments. Yeah. So here you go. This is what we're going to do. August 29, 2024, right? So ये सब कहानी हम लोग पहले कर चुके हैं. Multiple जो average enthalpy और ये सब चीज कर चुके हैं. What we're going to do now is the Born-Haber cycle. Now this may look complicated, but it's not. We'll do it step by step. It's the same thing. वही है जो पहले था कि Hess law है ना. देखो, delta H is a state function. Whether you do a reaction in 1 step or 10 steps, it is going to give you the same energy difference. And यही यहाँ पे main point है. We're going to use this. We'll check this out. इसको हम लोग discuss करेंगे. इसके अलावा क्या क्या करेंगे? Spontaneity, right? That's it. No, we'll spend a lot more time on a few other things. There's enthalpy of solution, enthalpy of neutralization. I see that it is mentioned in like half a line over here, like half a paragraph. एक line यहाँ लिखा है, बस. That's it. And ठीक है, थोड़ा सा और यहाँ पे लिखा है, right? Okay. Cool. We'll spend some time on these 2-3 ideas. यहाँ पे कुछ छोटा छोटा सा लिखा हुआ है. This is in a way related to bonding, थोड़ा बहुत, ठीक है? And it will also help you in equilibrium. So we'll spend some time on these 2-3 definitions. Maybe we'll do some questions also, क्योंकि as you know, JEE NEET में से सवाल आते हैं. So we get started. All good. Yeah, मेरी आवाज आप आ रही है? You will see me, hear me. Let me know in the comments. So let's get going. कहाँ गया ये? Yeah, here we are. First question, right, for you. Change in enthalpy इस reaction का क्या होगा? I've got peroxide, hydrogen peroxide, H2O2. That decomposes. क्यों decompose करे? अपने आप करे, हाँ कर देता है. To water and oxygen. तो heat of formation इन दो substances की दी हुई है. नहीं, हम लोग को दोनों की निकालनी है. We have to get the heat of formation of the. Right? What? How do we do that? Oh no, hold on. Heat of formation इन दोनों की दी हुई है. हमको change in enthalpy इस reaction निकाली. Oh yeah, this is doable. ये तो क्या है? Like hold on. For a second I was like, wait, what? How do you find out two things? Yeah, एक ही चीज पूछी गई है. They're just asking you what is the enthalpy of this reaction? Delta H R basically. Yeah. ठीक है, we can do this. So do you want me to help you with this? Will you try it out? I think you should try it out. काफी doable है. देखो, what is the idea of delta HF? Heat of formation का main concept क्या है? कि I am forming 1 mole of stuff, whatever it may be, formed. ठीक है? From standard states I know that, but 1 mole formed मतलब ये होगा right hand side के reaction में when you are writing the definition of these two. Okay, so we will do that. Okay, but in this case I've got this on the left hand side and this on the right hand side. So quickly, and आप लोग भी ये कर सकते हैं काफी जल्दी, ये RHS है twice, ये LHS है twice. So I will take water का formation as it is, which is -286, multiply it with 2, and I will reverse the sign of the other guy. और दूसरा क्या था? -186 and again into 2. क्यों reverse क्यों किया? क्योंकि ये भाई साहब है LHS पे. But also shall we see, are these standard states? Yeah, they are standard states. सब कुछ standard state में हो रहा है. अगर आप चाहें तो आप please do this exercise by yourself. हाँ, write down the actual delta HF का definition. क्या? H2 plus half O2 giving H2O, H2 plus O2 giving H2O2, gas, सब कुछ liquid, सब कुछ लिखो. And then you subtract and you do the same thing. Basically, ये reaction आप as it is ले रहे हो. This is taken as it is, right? Forward में ही. And you're reversing this reaction. अगर आप इसको reverse कर रहे हो, तो उसका sign हो जाता है inverse. Right? Inverse is the right thing, is it? Yeah, sign inverse. I think I should say that. Ken, this is it. So it should be positive something, right? इससे मुझे लग रहा है कि positive कुछ value आना चाहिए. No, hold on. -286 into 2. Oh, negative value आना चाहिए, right? -286 into 2, -186 into 2. Huh. That's interesting. That's very interesting. So what do you think the answer is? Can you give me a hand on this? 188, not 186. दाल में कुछ काला है. Shall we just do it this way? Can we just, simplify this? Use the awesome properties of maths that you've been learning from, I don't know, time immemorial. -2 बाहर निकाल लो and you do 286 minus 188. Can we just do that? Sure, absolutely. What does this give you? This gives you like a 98. 98 into 2 कितना होता है? 196. Yay, we have a winner, minus 196 kilojoule per mole. That's the answer. Let's move on. Let's move on. ठीक है? Yeah, what's up, Rinky? लगता है कोई मैथ्स में जब भी थोड़ा सा अरिथमेटिक होता है सब लोग थोड़ा बहुत come on, you got to be quick. Rinky, I feel it should be A minus. मैंने आपको जैसे दिखाया कैसे. Be careful about this. अरिथमेटिक में ही लोग मार्क्स लूज करते हैं, इसीलिए ये चैप्टर कुछ लोगों को मुश्किल लगता है, बट इट्स वेरी डूएबल. हीट ऑफ कंबस्शन डेल्टा एच सी H2 CH4 कुछ वैल्यूज हैं. then delta H इस रिएक्शन का क्या होगा? I'm again going to do the first principle. I'm not going to use those random formulae. मेन आइडिया क्या है कि हीट ऑफ कंबस्शन में यू आर टेकिंग X plus O2 gives XO2, यानी कि LHS में आपका ये स्पीशीज है. सो अगर इस इक्वेशन में भी ये LHS पे अपीयर करता है then great, we are not going to do anything with it. but अगर RHS में करता है we will put a negative sign around this. okay, so ये RHS में है तो we do minus of minus 213 and ये twice है H2 कितना था? minus 68. alright, and ये once है into minus 94. alright, बढ़िया. so we are adding 213, we are subtracting 134 and we are subtracting 94. look at that. what is this? I feel that the answer could be this. I mean, without even doing the calculation, because this is some 200 something and this is also 200 something. Right? So I think that should work out. कर लेते हैं, try करना है क्या? एक सेकंड, मैंने कुछ गलत लिखा है क्या? 134, 68 into 2 is not 134, it is 136. Amazing. Keep up the great maths, huh? 0. All right, great. Nil bate sannata and all. And this is what? 230? Yeah, okay. So it is minus 230 plus 213, which is minus 17 kilowatt calorie है क्या? Calorie है, ठीक है, किलो कैलोरी पर मोल. That's the answer. Doesn't take too much time. मैं इतना बात कर रहा हूँ, आराम से कर रहा हूँ, तब भी कर लिया हम लोगों ने. Yeah. I'm not sure what you're talking about YouTube, but description में link है. You can download the app from there if you like. All right, Suraj. That's great. Come check out my Discord channel. You can ask as many doubts as you want. You are looking for some advice on something specific. There are links to videos of everything like physics, chemistry, maths, bio. Actually, I don't have. I'll get NTNA भी by the way कुछ lectures दिए. So if you're looking for something, whatever you're looking for, सब कुछ मेरे Discord server पे है. Obviously, there are lectures on this channel as well. But if you want to do more, come to my Discord channel. Ask as many doubts as you like, and yeah, there are resources to do whatever. Yeah, come check it out, Suraj. All right, this is the answer to this one. Rinky, you try sir. Rinky, 170. Rinky जी, ये क्या किया आपने? 170 कैसे आया? Are you just giving me random options now? Come on, I don't like this. और पिछले वाले कब से बोल? No, what? How did you get C? Come on. Anyway, a quick summary of what we did last time. Very quick, like within 2-minute summary. Hess law of constant summation. यानी कि अगर आप एक स्टेप में करें, 10 स्टेप में करें, सेम होगा डेल्टा एच की वैल्यू, क्योंकि डेल्टा एच स्टेट फंक्शन कोई फैंसी चीज नहीं है. ये 3 हम लोगों ने डेफिनेशंस पढ़े. फ्यूजन, वेपराइजेशन, सब्लिमेशन. सब्लिमेशन क्या है? सब्लिमेशन है सॉलिड जाता है गैस. व्हाट इज वेपराइजेशन? लिक्विड जाता है गैस फेज में, फेज स्टेट. ठीक है, अभी फॉर अस इट्स बोथ द सेम. फ्यूजन क्या है? सॉलिड बिकम्स लिक्विड. ऑल ऑफ दीज आर एंडोथर्मिक प्रोसेसेस. एंडोथर्मिक यानी कि पॉजिटिव डेल्टा एच. अब why, what, how and all वो मैंने डिटेल में किया है. प्लीज वॉच लास्ट सेशन, इट वाज गुड फन. मुझे तो पढ़ाने में मजा आया. दिस आल्सो इज पॉजिटिव क्योंकि एंथैल्पी ऑफ एटमाइजेशन मतलब मेरे पास कुछ मॉलिक्यूल है, उसको मैं एटम से बना रहा हूं, तो मुझे एनर्जी देनी पड़ी. क्यों? बिकॉज एनर्जी रिक्वायर्ड टू ब्रेक बॉन्ड्स. एनर्जी इज रिलीज्ड व्हेन बॉन्ड्स आर फॉर्म्ड. एंथैल्पी ऑफ रिएक्शन कैसे निकालोगे? श्योर, देयर इज सम फार्मूला ओवर हियर, बट डोंट वरी अबाउट दिस फार्मूला. लुक एट दिस बेसिक आइडिया. एंथैल्पी ऑफ एटमाइजेशन या फिर बॉन्ड एंथैल्पी में क्या होता है? यू हैव सम बॉन्ड, राइट? से दिस बॉन्ड है एंड यू आर मेकिंग दिस, राइट? सो ये बॉन्ड है LHS में. मतलब कि अगर आपका whatever you need is on the LHS, then you take that as positive. अगर वो RHS में है तो negative, which means कि you take all the reactants minus all the products and obviously stoichiometric coefficients करो. देखो वही चीज यहाँ पे लिखी है, bond enthalpy of reactants, bond enthalpy of products, वही चीज लिखा था. ठीक है, आज क्या करेंगे? ये सब चीजें करेंगे. आ जाइए, अच्छा एक करके आएंगे. ठीक है, आइए एक करके आइए. Enthalpy of solution, lattice enthalpy and spontaneity. Looks like just बहुत 2-3 चीजें करने वाले हैं, but we'll spend some time. This is good fun. Okay, lattice enthalpy. YouTube, it's there, dude, in the description. You can download that. Yeah, The description will link here. You can download the app. You can check out whatever you want. But I think it gets paid after a bit. I don't think those videos are free, but you can watch some of it, like 2-3 videos. But you can after that, you got to buy the app. All right, we're gonna get back to this lattice enthalpy, and some of those animations I use there are gonna be in this session. So you'll be all right. If you want to learn for free, we've got everything. We've got you covered here as well. But the good thing about the app is it has awesome practice. It has great tests. So sure, go check it out. लैटिस एंथैल्पी. अब लैटिस एंथैल्पी है क्या चीज? देखो, दो तरीके से इसको हम डिफाइन कर सकते हैं. इन थर्मोडायनामिक्स राइट नाउ वी आर डिफाइनिंग लैटिस एंथैल्पी एज एनर्जी रिक्वायर्ड टू ब्रेक द लैटिस. अब लैटिस होता क्या है? व्हाट इज अ लैटिस? डेफिनेशन पहले पढ़ लेते हैं. एनर्जी रिलीज्ड व्हेन 1 मोल ऑफ अ सॉलिड आयोनिक कंपाउंड लाइक NaCl, सॉलिड ब्रैकेट में लिख देते हैं, इज फॉर्म्ड फ्रॉम इट्स गैसियस कॉन्स्टिट्यूएंट आयंस. आई, ये तो उल्टा हो गया. इट्स फॉर्म्ड, oh, so we take Na, which is solid, no, gaseous, ठीक है. That's weird. That gives it, that's so weird. That is lattice enthalpy. इसको हम लोग बोलते हैं lattice formation enthalpy, क्योंकि बन रहा है lattice. अब यार जब bonds बनते हैं, then it must be a negative value, right? एक्सोथर्मिक रिएक्शन. अगर बॉन्ड तोड़ना है तो पॉजिटिव वैल्यू है. सो डिपेंडिंग ऑन व्हाट इज गिवन टू यू, अगर आपको पॉजिटिव वैल्यू दी हुई है देन इट मस्ट मीन दैट यू आर ब्रेकिंग द बॉन्ड. इफ इट्स नेगेटिव देन इट्स फॉर्मिंग अ बॉन्ड. देखो, ये जरूरी है दैट यू अंडरस्टैंड दीस बेसिक्स. ठीक है, इफ यू वांट मी टू रिपीट एनी ऑफ दिस लेट मी नो, बट द मेन आइडिया इज कि लैटिस एंथैल्पी कैन हैव टू डेफिनेशंस. आई हैव डन दिस इन बॉन्डिंग एज वेल. ठीक है, कूल. या व्हाट डू यू मीन टू डेफिनेशंस? एक इस तरफ कर लो, एक उस तरफ कर लो. ठीक है, इफ इट इज फॉरवर्ड देन एनर्जी रिलीज्ड. अगर उल्टा है तो एनर्जी रिक्वायर्ड टू ब्रेक द बॉन्ड्स. ठीक है, लैटिस डिसोसिएशन एंथैल्पी इसको बोलते हैं, एंड इसको बोलते हैं फॉर्मेशन एंथैल्पी. व्हाट इज रिटन ओवर हियर. ओके, बहुत बात हो गई. इसका मतलब क्या है? बहुत ज्यादा एनर्जी हमने सप्लाई की टू ब्रेक दैट. NaCl परफेक्ट लैटिस था. लैटिस मतलब भाई अरेंज्ड ऑर्डर्ड स्ट्रक्चर. देखो, बहुत अच्छा ऑर्डर्ड स्ट्रक्चर, उसको हमने तोड़ दिया तो बहुत एनर्जी देनी पड़ी. दैट एनर्जी इज नोन एज लैटिस एंथैल्पी. ओके, ग्रेट. थोड़ा सा बैकड्रॉप दे रहा था. नाउ दिस बॉर्न-हेबल साइकिल कॉन्सेप्ट इज बेसिकली एन एक्सटेंशन ऑफ यही हेस लॉ. क्या? एक स्टेप में करो, 10 स्टेप में करो, सेम होगी वैल्यू. ये मैंने आपको शायद जब मैं पढ़ा रहा था डेल्टा H फॉर्मेशन के बारे में, आई गिव यू अ हिंट कि ये एक थियोरेटिकल आइडिया है एंड समटाइम्स यू कांट रियली फाइंड दीस वैल्यूज, सो यू हैव टू डू अ लॉट ऑफ भागदौड़ टू डू दिस. सो वी गोना लुक एट दैट. ठीक है, तो लैटिस एंथैल्पी निकाल सकते हो, डेल्टा HF भी निकाल सकते हो, ईदर वे, राइट. नाउ इसका आइडिया, व्हाट आइडिया वी आर गोइंग टू डू, राइट? वही बोला था कि नेट रिएक्शन का एनर्जी, नेट एंथैल्पी चेंज सेम होगी whether you do it one step or multiple steps. That's the main idea. So theoretically I've got solid Na plus half chlorine gas to give me NaCl. Now what is this? इस reaction का definition क्या है? What are we doing here? You can say combination, yeah, but you can say combination, but this is enthalpy of formation. Right, delta HF. Let's put a knot there. अगर ये 1 बार पे हो रहा है तो we can put knot also. Do you agree with me there? देखो, ये है गैस which is its standard state. इसका delta HF not is equal to 0. ये है सोडियम, ये भी स्टैंडर्ड स्टेट में delta HF not is 0. अगर इसका दोनों का 0 होगा तो how am I supposed to find this out? I have no way of finding this out. I want that delta H not F of this guy. So to do that we can do multiple things. There are things that we do know. What do we know? Theoretically, see, this is unknown, right? Let's take this as unknown. But what do we know? I know कि अगर मेरे पास एक solid सोडियम का एटम है और अगर मैं उसको गैस में बना दूं तो how much energy input do I need to give? That is enthalpy of sublimation, right? Solid से गैस जाने. So this I know. This is known. कुछ value है, some values. The numbers aren't important, but this is known value. Okay, great. Now I also know कि if I break this apart and I give me one chlorine atom अलग से, देखो, Cl2 is giving me this. These are two different species. Yeah, ये है atom, ये है molecule. So hence this is enthalpy of atomization और bond enthalpy बोल सकते हो. Either way, in this case is the same. So half the enthalpy, half क्यों? क्योंकि देखो, अगर मैं एक मोल लूं तो सब वैल्यू होगी. I just need one atom, so let's take half. So half bond enthalpy इसकी होगी. अच्छा, lovely. Where are we going with this? We'll see. देखेंगे. ठीक है, ये कर लिया. You know where I'm going with this, right? Now, अगर इन दोनों में से मैं ions बना लूं, किस टाइप के ions? I will get Na plus and I will get Cl minus and I will combine them and then that is lattice enthalpy. See? है ना? And this value also is known. So इन सब अगर value मेरे पास पता चलेगी तो this also I can find out. That's what we are trying to do. Yeah. Hey, Ram, how are you doing? ये क्या है, Na to Na plus, this is ionization energy, इसलिए मैंने बोला था कि पीरियोडिक टेबल ध्यान से पढ़ो. What is this electron gain enthalpy? This is minus 349 kilojoule per mole. Okay, मार्क करने की जरूरत नहीं है. Whatever it may be, not important. ठीक है. So कुछ वैल्यू है ये पॉजिटिव वैल्यू, कुछ नेगेटिव वैल्यू है. ओके, मिल गया. नाउ व्हाट हैव वी गॉट? one ion of Na plus, one ion of chlorine minus. Now if we combine both of them together, this is the value of lattice enthalpy. Okay, so now point क्या था, हमको निकालना है इसकी वैल्यू क्या है. How? Okay, now how with all this do I get that? Shall we just add them all up? I think we can add them all up. Let's just add them all up, right? Because what did I do? I'm taking 10 steps to go over. Maybe मेरे सामने कोई एक खाई है that I can't go over, but I'm going around it. That's exactly what's happening. Yeah. If you take the displacement, it's going to be the same. यहाँ खाई के उस तरफ. Chasm English में बोलते हैं, right? Anyway, so that's what we're going around. All these steps. We'll add all of these steps up, and what you'll get is delta H naught F value. And you can do this. अगर आप एक इक्वेशन लिखो, you'll see everything gets cancelled out, and you're left with is finally just this and the value you get. Yay! So we found this using this Born-Haber cycle. That's it. That's all Born-Haber cycle is. You can get a similar thing for magnesium or something else, MgOH or कुछ भी हो सकता है. But that's it. That's it. That's the theory behind Born-Haber cycle. It's not complicated at all. If any of these steps seem weird to you, please read the NCERT. ठीक है? इसमें कोई मैंने नई चीज नहीं की है. The only new thing maybe was enthalpy of atomization. We have explained that in the last session. It's the same as bond enthalpy. वो हम लोग बात कर चुके हैं. बाकी सब तो all of this you already know. And enthalpy of sublimation also may be weird. देखिए how on earth are you getting solid to gas? देखो solid से liquid बनाया, liquid से gas बनाया, तो दोनों को add कर लिया. So you get solid to gas. Because one step, two step doesn't matter. सवाल, quick question. अगर bond energies HH और Cl की दी हुई हैं and HF भी दिया हुआ है, तो bond enthalpy HCl की क्या होगी? HF मतलब delta H formation. Can we do this? Can we do this question? देखो ऐसा सवाल is very likely to come in your exams, which is JEE or NEET. Very likely. JEE में NEET में आने के बहुत चांस है. JEE एडवांस में नहीं आएगा ऐसा सवाल, but वहां आने के चांसेस हैं. JEE एडवांस में आएगा तो ऐसे 4-5 चीजें साथ में आएंगी. They've done that in the past. They'll give you like 5-6 of these things and they'll say, here you go, find it. Spend like 10 minutes on a random question like this. But not on JEE main and NEET. This is very relevant to JEE main and NEET. Okay, so let's do it. Let's take a hammer to it. Let's write everything down. सब definition को हम लोग लिख लेते हैं. क्या क्या चीजें लिख सकते हैं? What do we have to find? We have to find. Please try it out. Please try it out. Yeah. Anita ji, please try this question out if you want. Yeah. So bond enthalpy of HCl निकालनी. What is bond enthalpy of HCl? मतलब let's break bonds present in HCl. Okay. So I'm going to write that. ये मैंने अंग्रेजी में लिखा है. What HCl मतलब क्या होता है? Normally पानी में mix होता है ना HCl. So I'll put aqueous. So this is what is required. This is what the question is asking. This yellow stuff is this right here. Okay. That is unknown. What is known? There are 3 things that are known to me. तो उन तीनों का भी मैं reaction form लिख दूंगा. What do I mean? This is simply going to be H2 giving me 2H. This is simply going to be Cl2 giving me 2Cl. Sure, वो लिख लेंगे gases and all that. You fill in the blanks. And इसका क्या है? This is going to be half H2 plus half Cl2 giving me HCl. Write down all the states, standard states. So please लिख लीजिए. So that's what we'll do next. Yeah, 425 Ram. Thank you for that answer. That was very quick. Like it. Anybody else also want to try it? Or please try it. That's absolutely right. Good, well done. Simple सा question है, but you gotta do it quickly, right? यहाँ पे वही चीज लिखी है. 1, which is this guy right here. Delta HF is 1. Okay, formation. So I'm taking standard state, gases both, and I'm forming HCl aqueous. 1 more. Okay, cool. Technically, I could also put HCl as liquid. Or sure, okay, but let's take it as aqueous for now. Okay, then you take this is the atomization idea, which is the same as bond enthalpy 2 and 3. I'm going to write that here so it stays on this thing. 1, whereas 2 was this reaction right here, H2, and this was 3. Okay, right. Now, what do we need to get? We have to get this. This is what is needed. Now, इसमें है this guy on the LHS. This is on the RHS. So I'm going to multiply this with -1, which means I'm going to reverse this reaction. ठीक है. और क्या क्या है? यहाँ पे H और Cl RHS में है. यहाँ पे H और Cl RHS में है. But we got to put a half there. So as it is, but into half. That's all I've got to do. सो अगर इसको मैं मैथ्स करूं तो क्या हो जाएगा? Yeah, you guys agree with me there? I'm subtracting the first reaction and adding them to second and third by 2. That is the most important step. Once you got this, everything is sorted. It's not complicated at all, right? 90 plus whatever this is by 2. This is what? 670 by 2. 670, 335. 335 plus 90, 425. Right answer. Good job, Ram. Right? All right. Badhiya. Ek aur question. One more quick question. The standard enthalpy of vaporization for water at 100 degrees Celsius is some value. The internal energy of vaporization, this is a nice question. Internal energy of vaporization of water at 100 degrees Celsius is what? Yes, Srilata. Thank you. Huh. This question is interesting. I want to highlight what's important here. यहां पे एंथैल्पी दी गई है, इंटरनल एनर्जी पूछी जा रही है. अब एंथैल्पी और इंटरनल एनर्जी में क्या फर्क है? यू नो दिस ऑलरेडी, बट पहले रिएक्शन लिख लेते हैं, वो भी जरूरी है. रिएक्शन क्या हो रहा है? वेपराइजेशन, मतलब liquid becoming gas, and I'm going to write that reaction down. You guys please, जिसको आता है करने का, please go ahead and solve it. I'm just solving it धीरे-धीरे आराम से. So you see here the difference between this and this is just you've got one gas and the other side you've got liquid. How do we start this? Well, U is equal to H plus W, right? And then this, sorry, let's write it from first one. Is equal to delta H, Q plus W. That becomes delta U is equal to delta H plus W. That is delta U equal to delta H minus delta Ng RT. Ta-da! That's what you've got to do. वही आपको करना है, वही इसलिए मैंने यहाँ पे लिख दिया. ठीक है? अब number of gaseous moles क्या है? Gaseous moles, yeah, you've got 1 mole of gas over here. Delta Hg is equal to 1. So you've got to subtract something from delta H. तो delta H से थोड़ा कम होगा. 40.66 से थोड़ा कम. Actually मुझे एक ही वैल्यू दिख रही है. Hence this is the answer. खत्म. Don't spend time after this. If this is an MCQ and you're sure, you're confident about your process, just mark and Morse को calculate करने की जरूरत नहीं है. I know you're going to be attached to what if I made something wrong, made a mistake? No, you're sure. There's no way of going wrong here, right? You're sure that delta Ng is 1 and your whole process tells you that this is the expression. Matlab delta U is going to be lower than 40.66 and it's going to be positive, right? The only answer that fits is option A. Khatam. That's all. But we'll go ahead and solve it as well. If you're not confident about it, we'll go ahead and solve it, right? Substitute everything else. I have taken R to be 25 by 3 joule per mole per Kelvin. This is same as 8.314. Yeah, just like approximation. That's 25 by 3. I tend to do that. अगर liter atmosphere में liter bar में, you take it as 1 by 12, right? Yeah, that's the unit for that. Okay, cool, sweet. But this is a little weird. No, 373 आ रहा है. Why 1000? Because यहाँ पे kilojoule है. This is kilojoule. That's why I have divided the whole thing by 1000 because the answer also is asked in kilojoule per mole. Okay, cool. What do we do here? Well, simple तरीका ये है. Take it as 400 if you don't like it. और ठीक है, we can go do this slowly and steadily. 124, 125 ले लो. 125 is what? 125 is 5 cube. So take it as 5 bar 5. Right, so that's 625 into 5 by, yeah, 625 into 5, right, 3125. So you're subtracting approximately 3. That's what you do. 3.125 is what you're subtracting. That is 37.56. ठीक है, वो करने से भी same answer आता है. But as I told you, if you're confident about what you're doing, you can just mark this and move on. What's up, Aura? Good evening. Yes, Parth. बिल्कुल सही. Srilata. Yeah, absolutely. All right. Nice. Let's go and look at some other definitions. Enthalpy of hydration of gaseous ions. ये क्या वाला है? What is this? Enthalpy of hydration of gaseous ions. You saw Na plus gaseous and Cl minus gaseous वो hypothetical species थी, right? Hydration मतलब surrounding those ions by water molecules. Why will they get surrounded by water molecules? Water is polar. अगर if I've got ions in solution, they will get surrounded by water molecules and that process is called hydration. In what fashion? जो plus अगर ion है उसके अराउंड सारे ऑक्सीजन एटम्स आ जाएंगे, बहुत ढेर सारे ऑक्सीजन एटम्स. ये ऑक्सीजन हैज अ स्लाइटली नेगेटिव थिंग, राइट? यू नो हाउ इट वर्क्स, पोलैरिटी डिफरेंस एंड ऑल, राइट? एंड बाय नाउ यू नो दिस स्ट्रक्चर आल्सो, राइट? ये हम लोग पढ़ चुके हैं. सो इसीलिए दिस विल अट्रैक्ट द प्लस चार्ज एंड दिस विल अट्रैक्ट द नेगेटिव चार्ज, राइट? सो अ लॉट ऑफ वाटर मॉलिक्यूल्स सराउंडेड स्टेबलाइजिंग इट. सो हाइड्रेशन मतलब कि सम सॉर्ट ऑफ बॉन्ड इन अ वे काइंड ऑफ अ बॉन्ड फॉर्मेशन. मतलब ये एनर्जी नेगेटिव होगी, या दिस इज गुड, नेगेटिव होगी. That's important. Enthalpy change when 1 mole of a gaseous ion is hydrated in a large amount of water to form an aqueous ion. So the way you write it is gaseous and AQ. And I know it's weird, but this is what we do. Okay. Why am I telling you this? Because this brings us to my next idea. Enthalpy of solution. मतलब मेरे पास है, I have say solid NaCl. NaCl solid. मैंने उसको डाल दिया पानी में. What's the big deal? Yes, solvation. Umar, all right. Yeah, Ram, exactly what we're going towards. So NaCl है solid, so पानी में डाला क्या बड़ी बात हो रही है? देखो, पानी में डालना हमेशा चीजें डिसॉल्व नहीं होती हैं, और अगर डिसॉल्व होती भी हैं, they let off heat. What? Yeah. जब आप एसिड को पानी में डालोगे बहुत गर्मी निकलती है. You learn why in 12th standard. It's an exothermic process बोलते हैं. We'll try and understand पहले बेसिक चीजें. सॉलिड को मैं डाल रहा हूं तो क्या होता है. सॉलिड को अगर मैं डालूंगा तो वो सॉलिड पहले टूट जाएगा, और वो टूट के इट गेट सराउंडेड बाय अ लॉट ऑफ वाटर मॉलिक्यूल्स. से 2 स्टेप्स. सॉलिड को तोड़ना मतलब एनर्जी पॉइंट ऑफ व्यू से 2 स्टेप्स. एक्चुअली तो नेचर में क्या होता है किसको मालूम है. यू जस्ट पुट इट, यू सी इट, दैट्स इट, खत्म. राइट, बिफोर एंड आफ्टर. We can break it down to 2 steps, 10 steps. The 2 step I want to break it down is lattice energy. मतलब कि मेरे पास है lattice dissociation energy, NaCl, उसको मैं तोड़ रहा हूं. उसके बाद वो जो ions है solution में, they are being surrounded by water molecules. That's hydration. तो अगर इन दोनों की energy, overall energy ऐसी हुई कि is lower than the initial energy, then that process is awesome. If not, then the process doesn't happen. ठीक है? So definition के हिसाब से enthalpy change when 1 mole of a solute is dissolved in excess solvent so that further dilution does not involve any heat change. अंग्रेजी है भाई, हम लोग सब समझ चुके हैं. ये this is what happens, right? Boom, it breaks. Enthalpy of dissociation, and then this is a positive value, obviously, right? क्योंकि तुम तोड़ रहे हो, you're breaking bonds. And then the next step is that this gets surrounded by a lot of water molecules. Water molecules seem so tiny in front of these ions, right? And it's drawn, in a nice way to show you that those bigger balls are basically oxygen, and the छोटे लाल वाले are hydrogens, and they surround accordingly, and this energy is negative. अगर overall energy negative हुई तो अच्छा है, मतलब solution होगा. अगर नहीं हुई तो भाई it may not dissolve. That's what we are trying to say. So 2 steps theoretically: enthalpy of lattice enthalpy, enthalpy of hydration. ठीक है. Lattice enthalpy मतलब making gaseous ions. यार definition है, ठीक है, I know, like भाई gaseous ions कहाँ से आ रहे हैं? थियरी है यार. थियोरेटिकली वी आर सेइंग कि लेट्स हाइपोथेसाइज जस्ट फॉर फन. व्हाई? बिकॉज वी कैन मेजर दोस एनर्जी, इसलिए हम लोग हाइपोथेसाइज कर रहे हैं. ठीक है, दिस एनर्जी इज देयर इन डेटा. यू हैव टू सेट सम स्टैंडर्ड. ठीक है, इफ यू डोंट लाइक गैस यू कैन डू लिक्विड, बट इट्स वियर्ड. सो स्टैंडर्ड्स हैव बीन सेट कि दिस इज द डेफिनेशन, ओके, ऑफ लैटिस एंथैल्पी, कि तुम गैसियस आयंस बना रहे हो. ओके, उसके बाद हाइड्रेशन क्या है कि उसी गैसियस आयन में तुम पानी मॉलिक्यूल से सराउंड कर रहे हो. And it works because ये दोनों चीजें साथ साथ हो रही हैं when you put something in water. Enthalpy of solution क्या है? इन दोनों का addition. ठीक है? So enthalpy of dilution then would simply be, अगर मैं concentration उसकी कम कर रहा हूं, मतलब पानी डाल रहा हूं, तब जो है it's possible कि उससे भी enthalpy change हो. possible है. That's an extra thing. And another idea is कि अगर ये value negative हुई, then that is awesome. Right, which means that the stuff actually dissolves. अगर ये वैल्यू पॉजिटिव हुई then maybe ये डिसॉल्व ही नहीं करेगा. इसका आइडिया हम लोग यूज करेंगे इक्विलिब्रियम में नेक्स्ट टाइम. कि डिसॉल्व नहीं करेगा क्या करेगा? sparingly soluble salts, all that we'll study. Yeah, less Ka, more ions. अरे वाह Ram, are you giving JEE for the second time, or you already know all this? That's interesting. Or are you in college, Ram? I've asked you this before, I'm sorry I don't remember, but you know stuff inside out, man. That's great. Yeah, अरे यहाँ पढ़ ले यार. अब मैं राम कहानी क्या बताऊं तुमको, मैं तो पढ़ा रहा हूं, मेरे से पढ़ ले. Enthalpy of neutralization, that's the next topic that I'm going to look at. Neutralization मतलब you have an idea about this. Acid and base react, कुछ energy release होती है, या गर्म हो जाता है solution. If you react an acid and a base, scaringly hot. So definition is 1 mole of H plus reacts with 1 mole of OH minus to give undissociated water. अंग्रेजी ज्यादा हो गया, लिख लेते हैं, इक्वेशन फॉर्म में लिख लेते हैं. This is enthalpy of neutralization. Wait a minute. How does that make sense? What if I have, say, HCl and NaOH, or I have, say, I don't know, like barium hydroxide and H2SO4? Can I replace all of them with this? Yeah, absolutely. Because overall reaction is the same. I'll tell you how. Very, very soon. वही मैं यहाँ पे कर रहा हूँ, right? Now, you'll notice something that's interesting. अगर मैं इसको ध्यान से देखूं, इन दोनों इक्वेशंस में, and I write plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. इसका यही मतलब है कि ये आयन पहले भी था, बाद में भी है. बाद मतलब देखो, पहले बाद तो आप बोल रहे हैं ना, नेचर डजंट केयर पहले बाद क्या है. इट वाज देयर बिफोर, इट इज देयर आफ्टर, सो नथिंग इज हैपनिंग टू इट, सो यू कैन कैंसिल दोस आउट. दीज आर कॉल्ड स्पेक्टेटर आयन्स. सो ओवरऑल क्या हो रहा है, यही हो रहा है, ये रिएक्शन जो आप देख रहे हैं. द डिफरेंस बिटवीन बोथ ऑफ दीज इज कि यहां पे मोर हीट इज रिलीज्ड, स्पेसिफिकली ट्वाइस द अमाउंट ऑफ हीट इज रिलीज्ड, बिकॉज 2 मोल पानी बन रहा है. दिस बेसिक नो. अगर पहले वाले में 1 मोल पानी बन रहा है, दैट रिलीज सम हीट, दूसरा वाला 2 मोल पानी बन रहा है तो ज्यादा हीट निकलेगा. दैट इज ऑब्वियस, बट द रिएक्शन इज द सेम. क्या? H plus plus OH minus giving water, and that's a beautiful thing about acid-base reactions. Okay, irrespective of what acid reacts with what base, the overall expression, the reaction happening at the molecular level is the same. Yeah, and अंग्रेजी में थोड़ा यहाँ लिखा था ना कि undissociated water. अब इसका क्या मतलब? We'll study this later on in equilibrium, but what I mean to say is कि molecular water मिलता है, right? You have ions interacting, and what you get is a molecule that does not dissociate appreciably, right? करता है but बहुत थोड़ा सा. we'll study that in equilibrium. Okay, cool. What is this value? Why are we studying this? I'll tell you. Some value, big negative value, 57.1 kilojoule. Big because it may not sound very a lot when it comes to reaction. Reaction में मतलब ज्यादा एनर्जी होती है, like आपने देखा 400 जूल or whatever. But this is enough energy to heat up water. You know what is the specific heat of water? हमने अभी last session में ही किया था, right? 4.2 kilojoule per mole. है ना, किलोजूल पर मोल. ये क्या है? 57. मतलब गलती से अगर 1 मोल एसिड 1 मोल बेस आ गया तो दिस इज लाइक सम 15 टाइम्स दिस. यार इफ यू डू डिवाइड बोथ ऑफ दिस, अराउंड 15 आता है, राइट? 15 13 जो उतना भी आता है. सो यू हैव अ डिफरेंस इन टेंपरेचर ऑफ अराउंड 13 डिग्रीज इफ यू टेक 18 ग्राम्स ऑफ वाटर. डू द मैथ यार, मैं ऊपर से बता रहा हूं तुमको, बट बेसिकली बहुत टेंपरेचर फर्क हुआ. 13 डिग्रीज इज अ वेरी अप्रिशिएबल डिफरेंस इन वाटर टेंपरेचर, राइट? द टेंपरेचर ऑफ वाटर दैट यू टेक बाथ विद इज अप्रॉक्सिमेटली व्हाट, body maybe 50 degrees Celsius, right? And your body temperature is 36, so that's appreciable. Garam hai bhai, it's hot. Water gets really hot with this. That's what I was trying to say. Do the math yourself. Don't get confused with this. Okay, what's the point of doing all this? This is for a strong acid and a strong base. Like, huh? What do you mean? Yeah, strong acid like HCl. Strong base like NaOH. What is a weak acid? Oof, what is a weak acid? Weak acid, weak base क्या होता है? This is a little interesting and we'll do this again when we do equilibrium. Weak acid ये होता है कि मैंने डाला तो 1 मोल solution में, but it does not furnish 1 mole of H plus ions. It furnishes a smaller quantity, right? जैसे कि I've got some weak acid HA and I've got HCl. HCl will give me 1 mole. This guy is going to give me, I'm not even making this up, like 10 power minus 3 mole or something. Some ridiculously tiny number. Equal amounts. Again, but very small number, right? So this one is weak, this one is strong. इसका क्या मतलब हुआ? सिंपल सी बात है ना? ये लिमिटिंग रिएजेंट हो गया फिर, right? If I have a base in it, weak acid है, base same है, I react with NaOH. सिंपल सी बात है, right? I have 1 mole of this, 1 mole of this. They'll react, they'll give me this some big value. अगर 1 मोल ये बनाया नहीं ये बेचारा, and these are things get a little complicated. ठीक है? If I go into detail, it won't make sense to you until we do equilibrium, but take it as a statement of fact right now कि ये होता है and the base is still able to extract all these protons, but the energy release is lower. Let's just leave it at that for now. तो अगर energy इस value से कम हुई per mole of H plus ion furnished, then you know that you've got a weak acid and a weak base. ठीक है? Let's put some numbers to it and do a quick question. You're in 12th? अच्छा, makes sense, Ram, makes sense. All right, great. Arey Ram, you should come check out the equilibrium videos. I mean the AP 12th grade videos में NEET पे कर रहा है. I think कभी-कभी बीच में आप आते हैं. Yeah, you check those out. Those are fun. मुझे मजा आ रहा है यार ऑर्गेनिक पढ़ाने में. Let's take a quick question. The heat of neutralization of 4 acids PQRS are some value, and another value. When they are neutralized by a common base, what is the acidic character of these? Here's a quick question. क्या वैल्यू 13.7 से ज्यादा हो सकती है? ज्यादा तभी हो सकती है अगर point number 1 your base is in excess, point number 2, and actually that should be point number 1, you don't have a 1:1 acid. Instead of HCl you use H3SO4 or some other acid that furnishes more than 1 H plus ion in solution. So yeah, but if you have a 1:1 then it cannot be more than 13.7. That's like the limit because that's the maximum heat is released. Easy question. Maximum value is P, next is S, then is R, and then is Q. PSRQ. B is the right answer. Good job, Ram. Yeah. Strong acid का ये हो गया और as pure ion the furnish, weak acid, blah blah, कम हो जाता है. ठीक है. Great. Good job. Nice. Let's do 1 or 2 practice questions. एक दो और सवाल कर लेते हैं. Bond energy 3 substances की दी है. NH bond, HH bond and triple bond in. What is delta H for this reaction? Idea बहुत straightforward है. I'll give you about 30 seconds. I'll give you 1 minute to do it. Entire एक पूरा minute. People on the chat. Timer 1 minute.
1 minute counting down.
Yeah, this works, right? You gotta break those bonds. तो अगर sound like break those legs, like one of those mafia things to say. Anyway, ये bond को तोड़ना है. मतलब बॉन्ड तोड़ने वाला प्रोसेस अगर लेफ्ट हैंड साइड में है देन टेक इट एज इट इज, अगर राइट हैंड साइड में है तो उसको नेगेटिव करना है. तो लेफ्ट हैंड साइड में सिर्फ अमोनिया है तो यू हैव NH बॉन्ड, सो यू टेक NH बॉन्ड्स एज इट इज. 6 हो गए ना, 3 है into 2 तो 6 NH बॉन्ड्स ऑन द लेफ्ट. तो यू ओके, सो इट्स ईदर दिस और दिस, नॉट दिस, बिकॉज 6A नीड्स टू बी ऑन द लेफ्ट हैंड साइड. ओके, एंड यू हैव टू सबट्रैक्ट बोथ ऑफ दीज अदर थिंग्स. अगर यू हैव टू सबट्रैक्ट बोथ ऑफ दीज, not even looking at the number, the only one that fits is A. खत्म हो गया आंसर 15 सेकंड में. If you want to spend more time on it, you can. How do you spend more time on it? N2 मतलब I have, एक मिनट, ये बैलेंस्ड है ना? नहीं बैलेंस नहीं, बैलेंस है. एक मिनट. अच्छा ये C है ना? हाँ, माइनस C इज दिस एंड ये 6 हो गए HH बॉन्ड, 6 नहीं सॉरी 3 हो गए HH बॉन्ड. So this is minus 3B which is A. हाँ भाई बंद हो जा, समझ गए. कूल, सिंपल वन, सिंपल वन. Janvi, I'm not sure, dude. I have no idea. I understand your concern. Hey, Janvi, you can check out the last year sessions. We've been running the channel since 2021, right? In fact, I was on the initial videos. I don't know if you've seen those. Obviously, आपने नहीं देखा होगा. But 9th, 10th channel, we've done it for 1 or 2 years. So I know that some people are pinging. आपने बोला एक और another person also said. Anita also pinged. Please check the last year के videos. The content has not changed. So please check those out. ठीक है? Humble request to you. Let me continue what I was doing here. So yeah, तीनों चीज हमने लिखी and as Ram pointed out, it's A. It's easy question. One more question. When a certain amount of ethylene, CnH2n, this is a double bond creature, was combusted, बहुत ज्यादा हीट निकलती है और हीट ऑफ कंबस्शन ऑफ एथिलीन दिया हुआ है आपको. कितना O2 निकल रहा है इस रिएक्शन में? अच्छा, कितना O2 डाला गया? हाउ मच O2 was supplied? Now this is very possible to come as a JEE main question with a numerical entry. अगर ये नीट में आया तो it could come with options like this, but if I were to set the paper, I would put a question like this in JEE main with a numerical entry, would not give you options. यहाँ पे this is a 3-layered question. Layer number 1, you need to know what on earth C2H4 is. I mean, that's an easy one. I know, बहुत simple है, but you need to know that. Without that, you can't start. So you got to write that C2H4 is basically this. Yeah, that's the first step. उसके बाद, the second step is balancing this awesome reaction. That's the step number 2. Yeah, this is step 2, balance. Step 1 is इसका structure. Okay, what is step 3? Step 3 is after you balance and you do all of your awesome things and somehow you've got इसके कितने moles होंगे, right? You've done this. After that, you got to do mole proportional to volume and then you get volume. So that step 3 is figuring out moles. How do you do that? अच्छा, x moles के लिए आपको निकलता है 1411 नहीं हाँ कुछ मतलब एक मोल C2H4 के लिए आपको मिलता है 1411 किलो जूल. तो x मोल के लिए कितना निकलेगा? तो उससे you get moles and then you do all this. This is the process to do this question. Yeah, I understand. or absolute Janvi, I completely agree with you. Oh yeah, you do? That's awesome, dude. That's awesome. Hey Janvi, if you have any doubts, come join my Discord channel. Although most of the doubts, most of the people there are 10th, 11th, 12th students and maybe some 10th graders. But yeah, come. You can join. Tell your friends to join. The link is on the description and also a pinned comment, Janvi. Bento link. Click on the Discord thing. Join there. Ask as many doubts you want. It's completely free, and this is for everybody. It's not just Janvi. किसी के लिए भी है. Telegram groups भी मैंने बनाए हैं. Why am I so confident about them? Because there are a lot of students there. There are like 750 students. They solve each other's doubts. So even if I'm not always around to solve doubts, people will help you out. Physics, chemistry, math, bio, कुछ भी पूछो. I've had people ask things about coding and all stuff. So जो पूछना है पूछो. And we have a lovely community. Anyway, जब तक मैं ये सब ज्ञान दे रहा था, did anybody solve this question? It takes a little bit of time to do this. I understand that. So how do we do this? How do we do this? So I'm going to write down step 1 and 2 right now. ठीक है? Balance किया हुआ. And please, for the love of God, यार ये सब मग मत करो कि x plus y by 2 ये सब नहीं करने की जरूरत है. ये सब simple चीजें हैं. कर लो यार. Takes you 30 seconds to do this. ठीक है? How do I do this? I can tell you how to balance this. C2H4S, so I put a 2 over here because of this 2. Okay. H4S, so I put a 2 over here because of this. That's it. Now these two are already balanced. So all I have to do is figure out water. And water may, this is as it is and this is ka half. So 2 plus 2 by 1. Interesting. What? I'm a little flabbergasted. It should be 2 by 2 here. Like wait, एक मिनट यहाँ पे यहाँ डिनोमिनेटर में 2 होना चाहिए 2 by 2 है. खैर, so totally 3 मोल ऑक्सीजन चाहिए तुमको. तब 3 मोल ऑक्सीजन अगर है तब आपकी इतना हीट निकलता है. But x mole में कितना निकलेगा? This is supposed to be a 2. I'm going to keep changing every slide. Don't worry about it. So this is approximately 3 or what? No, it's not 3. It's some other number. We'll have to see. It should be 3. No, it's 4. Yeah, it's 4. Okay, cool. So 3 is this. X is how much? This should be 4 moles, I guess. So 4 into 3 मतलब 12 mole हो गया of oxygen. So 12 mole oxygen gives off this much heat. Now, what is the volume of 12 mole of oxygen? Okay, 12 into 22.7. That's the answer. 272.0 ml. No. Liters. Yeah, liters. B should be the answer. Not ml. Be careful. Yeah, it's liters. Good. We good? Yeah. 302. Yes, Ram. बिल्कुल सही बोला आपने. All right. I understand this would take time. Yeah. And आजकल, at least this year and the last year में ऐसे सवाल JEE में तो नहीं आए. Right? इतने effort वाले सवाल नहीं आए JEE में. I'm being straight with you. At least not in chemistry. But अगर आ गए then you are prepared for it. Maths, थोड़ा सा arithmetic है. Hey, this looks like the India flag colors, right? You've got orange, you've got white, you've got green. Looks pretty cool. And the blue. Yeah. All right. एक और सवाल देख लेते हैं. We have time क्या? एक सवाल और देख लेते हैं. Then we'll see. Which of the following is not correct? कौन सा option not? Ram, this is fine. ये solution ठीक था. Is this okay? Yeah. Process is all is fine. Please take your time and actually solve it. Yeah. I'm not in any hurry whatsoever. But if you guys interact with me and you ask me doubts, I'm here. But if that isn't happening, then I'm going to continue. That's the goal of these live things. Yeah. So ask me जो भी आप चाहें. और अगर इसको देखने के बाद आपको कुछ doubts आ रहे हैं and they're not being addressed, go to the Discord channels. Ask as many doubts as you like. Okay, which of these is not correct? Breaking of a bond is endothermic and formation of a bond is exothermic. I like this question. I like this question already. Neutralization is always exothermic. अरे वाह, ये वाला तो सही है. मैंने आपको ऑलरेडी बता चुका हूँ क्यों. ये तो सही है for sure. The absolute value of enthalpy can be determined experimentally. ये तो philosophical सवाल हो गया. अच्छा, the heat of reaction at constant volume is denoted by delta U. Last वाला सही है. This is definitely true. I've taught you this. How do we know the last one is true? Delta U is Q plus W. Okay, cool. What is W? This is P delta V, P external times delta V. अगर आप irreversible process लो तो, or you can do integral also, whatever, doesn't matter. But the point is कि अगर constant volume है, then delta V turns to be 0, which means that delta U is equal to QE. And also, on a side note, delta H is QP. So this is correct. So गलत कौन सा हुआ? Breaking of bond is endothermic. Absolutely. Yeah, this is how I remember it. So when you clap, that's like magnets coming together, releasing some sound, right? Tuck आवाज आती है. And अगर कोई magnets अटके हुए हैं, you have to pull them apart. So to break a bond, you require energy. And as soon as bonds are formed, magnets whack each other, some sound energy is released. So this is also correct. The incorrect statement is this: you can't possibly find out absolute value of enthalpy. Yeah, you can't. आप सिर्फ energy या enthalpy difference को study कर सकते हैं. Yeah, not the absolute value. That's the answer of this one. What's up, Aditya? How are you doing? All right. We're done with most of the session today. Let's move to the next part of this, which is spontaneity. कुछ चीजें होती हैं जो अपने आप होती हैं, that is what we call spontaneity. मतलब कि कोई चीज गर्म रखी है यहाँ पे, हाँ ये काढ़ा मैंने यहाँ पे रखा है, एंड कुछ समय बाद अपने आप देखो टेम्परेचर गिर जाता है, अपने आप कुछ किए बिना, जस्ट रख दो, इट हैपेंस ऑन इट्स ओन. दिस इज कॉल्ड स्पॉन्टेनियस. बट उल्टा अगर मैं करना चाहूं तो भाई मुश्किल है. इफ आई वांट टू हीट इट अप, that doesn't happen by itself unless मैं जाके बाहर सन में रखूं. that's a different thing. ऐसे right here in this room. तो गर्मी करने के लिए क्या करना पड़ेगा? गर्मी I have to provide heat to it. मतलब doesn't happen on its own. There's some external stimulus that I do over there. Check this one out, right? यहाँ पे I've got this wall. Oh, that happened very quickly. This is a spontaneous thing right away. There's some gas molecules एक half में, and the moment I remove that, अपने आप जो है it spreads out. This also looks like it happens on its own. Okay. Now, अभी तक हमने जो पढ़ा है, which is whole delta H, delta U, neither of these things can predict कि ये क्यों हो रहा है या किस डायरेक्शन में हो रहा है. मतलब कि वो टेम्परेचर गिरेगा कि बढ़ेगा, या फिर ये जो है फिल अप करेगा या नहीं करेगा. Everything we've done so far does not help you do that. Okay, doesn't help you figure out direction of spontaneity. Direction क्या मतलब है? वही ना, टेम्परेचर कम होगा बढ़ेगा, या फिर ये गैस एक्सपैंड होगी या कंप्रेस होगी. Doesn't tell you that. That's direction. Okay. So what do we do? We're gonna do something else. थोड़ा सा और हमको एफर्ट लगाना पड़ेगा. जनरल आइडिया है कि स्पॉन्टेनियस प्रोसेस ये है कि समथिंग हैपेंस ऑन इट्स ओन. नेचुरल टेंडेंसी है कि वो प्रोसेस हो जाता है. और नॉन स्पॉन्टेनियस मतलब कि अपने आप नहीं होता है. इट नीड्स सम एक्सटर्नल स्टिमुलस, मतलब कुछ इट नीड्स अ पुश बेसिकली, फॉर द लैक ऑफ अ बेटर वर्ड. थोड़ा आउटसाइड रेजिस्टेंस चाहिए. सो नाउ गिव मी इनपुट्स. गिव मी सम इनपुट्स टू LOT. What is LOT? I don't know, man. Aditya, depends on your whole thing. It's not just chemistry. You need all of them together, right? Oh, you want just some person telling this thing? I don't know. Look, man, I'm not the right person to say, hey, इतना करो और इतना marks मिल जाएगा. I'm not a shoe salesman or whatever, you know, or not shoes. Sorry, इसको क्या बोलते हैं? साबुन salesman नहीं है कि हाँ ये करो और ये दाग चले जाएंगे. Yeah. Anyway, so जब चीजें अपने आप evaporate हो रही हैं, so I think this is a spontaneous process, right? This is the first question. Is it spontaneous? Yeah, definitely spontaneous है, क्योंकि अपने आप पानी में बाहर रखो, because of सूरज की किरणें पानी evaporate होता जाता है. Okay, cool. What about boiling of water? Is this a spontaneous process? Boiling मतलब what is boiling? When vapor pressure, maybe you don't know this right now because for some awesome reason they have removed states of matter from your syllabus. Vapor pressure equal to atmospheric. I'm going to still write it anyway. Whenever you read it, whenever you do kinetic theory of gases and all of that, or you do solutions, you will read this. This is the definition of boiling. Matlab, what you're going from is a liquid to a gas. If you want to know what on earth is vapor pressure and all of this, watch my states of matter sessions. Again, they're on the bento links. So if I get to a point where I'm at boiling temperature, then yeah, it happens on its own. What about gas to liquid? उल्टा, हाँ दोनों चीजें होती हैं. Actually, at the boiling point दोनों चीजें होती हैं. That's interesting. ठीक है. So there are some processes that happen on their own and some processes that don't. Like for example, yeah, look at this process right here. Yeah, अगर मैं किसी चीज को compress कर रहा हूँ, is that a spontaneous process? What do you think? Is that spontaneous? Oh, second law of thermodynamics, right? I see that. Equilibrium boiling point. Yeah, absolutely. Is this can you help me with this? क्या ये spontaneous process है? Which of these? There are two things that are happening here. एक compression, दूसरा expansion. इसमें से कौन सा spontaneous process है? और दोनों spontaneous है, एक spontaneous है. Think about like this. If you have ever played a sport, the ball वाला sports में हवा भरनी पड़ती है. जब आप उसको press करते हो, you have to physically press the thing down to fill air, either with your hand or your foot. So that doesn't seem very spontaneous. But वो जो वापस बाहर आता है वो अपने आप आता है. So that is spontaneous. The expansion process is spontaneous. How do you predict this? How do you predict कौन सा spontaneous है कौन सा नहीं है? Yeah, सिर्फ डेल्टा एच से तो आप कर नहीं सकते हो, right? एंथैल्पी से नहीं कर सकते हो. So for example, like here, ऊपर से नीचे है, हम लोग जा रहे हैं. Oh, high potential energy, low potential energy. हाँ, ये spontaneous है. High potential, low potential. ठीक है. This we can predict the direction of spontaneity. ऊपर से नीचे आ रहा है, ऊपर हाई पोटेंशियल एनर्जी है, नीचे कम है, तो डेल्टा एच इज नेगेटिव, तो स्पॉन्टेनियस हो गया. बट व्हाट अबाउट दिस? देयर इज नो डेल्टा एच आइडिया. डेल्टा एच जीरो है, मतलब एंथैल्पी पहले जितनी थी अभी भी इतनी हो रही है, बट कुछ और है दैट इज चेंजिंग, because of which we can say that, oh, look at that, this process is spontaneous. That's what we're going to study next time. Entropy is what it's called. Spoiler alert. ठीक है. So before you this partition happens, आप अगर left side right side में देखोगे तो you will know for sure कौन सा molecule है. But as soon as that partition goes away, you'll be like, I don't know, man. Any particle can be picked up. It's completely disordered. ये disorder शब्द is what is going to help you understand this concept of spontaneity. जहां ज्यादा disorder हुआ, that is the direction that the universe tends to do. What is universe? System surrounding बड़ा था पहले सेशन में, system plus surrounding universe, मतलब everything tends to get more disordered. Cool. Yes, आर्गदीप बिल्कुल सही बोला आपने. So here are some observations, right? ये process delta H positive है. You may think कि delta H negative process spontaneous होता है. Here is an example, देखो यहाँ पे endothermic process हो रहा है, but this is spontaneous, अपने आप होता है ये, मेल्ट होता है लिक्विड, ठीक है, मेल्टिंग ऑफ आइस एट रूम टेम्परेचर हो जाता है, एनी टेम्परेचर ग्रेटर देन 0 डिग्री सेल्सियस. सो उस टेम्परेचर से ज्यादा, सो टेम्परेचर हैज सम इफेक्ट ऑन स्पॉन्टेनिटी. यू आर एबल टू सी दिस. 0 डिग्री से ज्यादा टेम्परेचर पे अपने आप होता है, मतलब टेम्परेचर हैज सम इफेक्ट ऑन स्पॉन्टेनिटी, सम इफेक्ट. ओके, दूसरा क्या है? इवेपोरेशन इज स्पॉन्टेनियस. अब इसका कैसे देखिए, कैन वी ड्रॉ एनी कंक्लूजन फ्रॉम दिस? देखो, इवेपोरेशन मतलब हीट होती रहती है, हीट. सो हीट हैज सम इफेक्ट ऑन स्पॉन्टेनिटी. या व्हाट इज इवेपोरेशन? हीट आ तो रही है ना, देयर इज क्यू इनपुट, कहां से? सन, SUN नॉट SON, द सन, सूरज से हीट आती रहती है, तो हीट हैज सम इनपुट ऑन स्पॉन्टेनिटी. इस पिक्चर से क्लियर नहीं होता है, बट व्हेन यू गो बैक टू सी इवेपोरेशन होता क्या चीज है, देन यू रियलाइज टेम्परेचर तो सेम है. से लेट्स अज्यूम कि सारे दिन, 10 दिन जब ये देख रहे हैं टेम्परेचर एग्जैक्टली सेम है, तब भी ये इवेपोरेशन होगा. क्यों? क्योंकि देयर इज अ कांस्टेंट हीट बीइंग एडेड. सो टू आइडियाज, टेम्परेचर एंड हीट, बोथ ऑफ दीज इफेक्ट स्पॉन्टेनिटी. ठीक है, आई एम गोइंग टू राइट दैट डाउन. टेम्परेचर एंड हीट affect spontaneity. But you'll be like, bro, this thing had nothing to do with temperature or heat. This thing is temperature heat दोनों की बात नहीं हो रही. I know ये थोड़ा और complicated चीज है. This has to do with something called disorder. We'll talk about that next session में. ठीक है. When you go from a solid to liquid, things get more disordered. If अगर ये this is difficult to understand, liquid to gas तो definitely ज़्यादा disorder हो रहा है. Gases are free to move around. Liquids, solids are confined. Liquids have all the space in the world. This is the concept of disorder that I was talking about. जो उस even not gases, confined gas से जो है not so confined gas, वहां पे भी वही same idea use हो रहा था. Is this all right? I know ये थोड़ा abstract है. From now on, the thermodynamics that is left थोड़ी सी abstract होने वाली है. I've given you a fair warning. So, अगर मैं किसी सिस्टम से हीट या मास आने जाने नहीं दे रहा हूं, उसको हम लोग आइसोलेटेड सिस्टम बोलते हैं. उस केस में अगर डिसऑर्डर बढ़ रहा है, तब सिस्टम स्पॉन्टेनियस हो सकता है. दो चीजें मैंने बोली. एक, आइसोलेटेड सिस्टम मतलब हीट अंदर बाहर नहीं जा सकती है, मास अंदर बाहर नहीं जा सकता है. आइसोलेटेड सिस्टम मतलब वही बाउंड्री आइसोलेटेड होती है ना, लाइक थर्मस फ्लास्क. There's a general tendency for it to get disordered, and that is what this concept of spontaneity is. So the driving force is some attaining lower energy. देखो, कोई भी process होता है, attaining lower energy is always the main goal. And the second thing is more randomness or disorder. And to measure that randomness or disorder, we use something called entropy, which is S. This is a new state function, and it is. There were two things we learned. You remember? Intensive, extensive. Just like delta G, entropy भी extensive property है. मतलब it depends on number of particles. Very important. And just like enthalpy, डेल्टा एस इज प्रोडक्ट माइनस रिएक्टेंट, डेल्टा एच भी वही था, सेम चीज हो रही है. सो ट्रीट इट लाइक डेल्टा एच बट इट्स स्लाइटली डिफरेंट. ये थोड़ा एब्स्ट्रैक्ट होने वाला है, आई एम टेलिंग यू बार बार, बिकॉज ये जरूरी है कि यू अंडरस्टैंड दैट इट्स ओके टू नॉट अंडरस्टैंड दिस कॉन्सेप्ट कंप्लीटली. वी कैन अंडरस्टैंड इट मैथमेटिकली, इसका मैथमेटिकल मॉडल बना सकते हैं एंड जनरल सॉर्ट ऑफ फीलिंग इसके बारे में ले सकते हैं, या कि why is that thing trickling down? Anyway, yeah, solid ये है, liquid ये है, gas ये है. Great, okay. I'm not sure why this is happening, but basically just trying to shake entropy. But in all these three cases, the entropy is increasing. Yeah, you do all these three things, the entropy increases. Yeah, and it's more relevant. The entropy increase is more relevant in gases. ये दिख रहा है ना? What this trying to say is कि मैं gas इसको roll down नहीं कर रहा हूँ, still solid. लिक्विड को रोल डाउन कर रहा हूं, वो ज्यादा अभी थोड़ा ऑर्डर है, ज्यादा डिसऑर्डर हो रहा है, और गैस को खोलूं तो ज्यादा डिसऑर्डर हो रहा है. सो क्लियरली गैस इज मोर डिसऑर्डर्ड, एंड इफ यू आर गोइंग फ्रॉम अ लिक्विड टू अ गैस, इज गोइंग टू बी spontaneity is going to be higher. Yeah, the disorder state or disorder is going to be much higher. So that was just to give you a bit of an intro into spontaneity. ठीक है, spontaneity क्या है मैंने आपको बताया, और थोड़ा बहुत इंट्रोड्यूस किया कि एंट्रोपी क्या है. So for you guys, the goal is to go ahead and read from NCERT. And if you want to do a little bit more, go check out my sessions. Yeah. और भी पढ़ना है तो एबिंग बहुत प्यारी बुक है to read. Hold on, I'm going to open it up and suggest this. Yeah, entropy and spontaneity. Yeah. So yeah, this is the stuff that we've pretty much covered. We're going to do this next time. ये मैंने बताया था ना, देखो heat and temperature. यही चीज मैं आपको बता रहा था. This is what we'll do next session. And it's important that you realize कि Q reversible is different from Q irreversible, right? But it doesn't matter if your process is spontaneous, not spontaneous, reversible, irreversible. The definition of entropy is always going to depend only on Q reversible. This part is a little bit, sometimes students feel that it's a little random. No pun intended maybe. But please read up on this अगले session से पहले. It'll help you a lot. This part of thermo is very abstract, but it's still scoring. It's fine. We'll get marks in JEE and NEET. But थोड़ा abstract तो है. It's fun if you like the math. Okay, that's all I had planned for you today. I'll see you around and have fun. And if you guys have any doubts outside of this class, when you're not asking this live or you're watching it later, come onto the Discord channel that I've pinned on this. It'll keep running. Come there, ask as many doubts you like. ठीक है? Thanks, man. Thank you everybody for your time. See you around. Bye. And if you like the video, share it with your friends as always. Bye.